Estimating the slope of a tangent given an equation, secant method 2. In order to illustrate this subject, we're going to use the function f of x is equal to x to the power of 3. Under this window, we're going to go 0 to 3, 0 to 5, which produces a graph that looks like this. And we're going to concentrate on what the slope of the tangent would be at x is equal to 1. Alright, here's y is equal to x to the third, and specifically we are interested in finding what the slope of the tangent, or the slope of the function, however you'd like to say it, is at this point. I know this tangent line isn't quite on the line, but I'm trying to do that to help you see the difference. So here's what we've done before. We've typically always chosen a point further away, usually to the right, and then if I draw in this secant, what we found is it's a decent approximation and becomes really good as we get close from this direction. We're going to take a little different spin on this now. To make it simple, here's the idea that we're going to go with. We're going to keep that point of tangency where it is, and instead of just choosing a point to the right, we're going to choose a point, in this case, of kind of equal distance to the left. And as you can see, if I connect these two together, I get a secant here, I get a secant here, and you're going to notice it's going to sandwich my tangent line in between them. So here's the theory. This isn't the slope, but let's say that this slope was 10 and this slope was 6, then it would seem to be reasonable that I would simply average those two numbers and come up with a pretty decent approximation of the one in between it. So we're going to do that, and I'm not going to go with this estimation method, but we're actually going to use real numbers and then the same idea to estimate instead of taking one point and moving it infinitely close. Here's what that looks like. Here's the number choices we're going to go with, and this is by no means drawn to scale, but if this is 1 and this is our other point of tangency, let's make that just a normal secant point, and then this point over here, here's what I like to propose. Why don't we call this one down here 1.001, which is very close to 1, and then let's make this point in this location 0.999. And then what we'll do is actually run the numbers through for the function y is equal to x to the third. We'll have a table of data, and then let's actually run the numbers and see how it works out. Okay, making sure that my independent variable is set to ask and that I have the equation y is equal to x to the third on y1. I'm going to go into my table, and if there are any values in there, you can delete them very easily. And again, the numbers we're interested in are 1, 1.001, and 0.999. And this really should be everything that we need to know. So all I did here is I took the points that were given to me in the table, and then remember these are simply just ordered pairs, and then I paired these two together and these two together, and then the next thing we'll do is actually use the slope formula to find the slope of those two secant lines. So here's how that work turned out. Again, all we're doing is just choosing ones that are close, and this isn't the only option, but for these two ordered pairs, here's the work, here's the slope, and for these two ordered pairs, here's the work and here's the slope, and they're the same. Oh my gosh. And remember, all we'd have to do is simply average these numbers together, and since we chose such values that are as close as they are, their average is of course 3. Graphically speaking, if they're not exactly the same, and that will happen, just think of it this way: one is 3, the other one is 3, and it's just a matter of sandwiching those together with an average to find the one that we need. So in this case, the slope of the tangent would be 3. In summary, to estimate the slope of the tangent to a curve, here's your point of tangency. Make that a little bit bigger point so you guys get the idea. And then what we're going to do is choose one point to the right, make it secant. Choose one point to the left, make it secant. Take this number, and simply average those two. And that's going to give you a pretty good number. It gets better as you choose them closer and closer together.